Hello mga kamad solver, my name is John Russell Nobleza.
And my name is Alan Scaly Reyes.
Welcome to Group 2 presentation.
And our topic for today is solving exponential equations and inequalities. Are you ready, guys?
Listen.
Learn!
And enjoy!
Let's talk first about exponential equation and equating exponent property. Exponential equation is an equation involving exponential expression. In solving exponential equation, the equating exponent property is used. It states that in an exponential equation, if the bases are equal, the exponent must also be equal. Or if the exponents are equal, the bases must also be equal. Let a, b, and c be real numbers and a not equals 0. If and only if b equals c, then a raised to b equals a raised to c. Let's have an example.
Solving exponential equation. Example number 1. Solve 2 raised to x minus 1 equals 32. Step 1. Rewrite the equation so that the bases are the same number. When we will rewrite it, it will become 32 as 2 raised to 5. Step 2. Once the bases are equal, you can see the exponent equal to each other. Equating exponent property and solve. Our example is 2 raised to x minus 1 equals 2 raised to 5. Apply it to equating exponent property. The answer is x minus 1 equals 5. And transpose negative 1 to the right so that it will become positive 1. Our answer is x equals 6. So, let's check. Substitute 6 for x, we will get 2 raised to 6 minus 1 equals 32. And let's simplify. We will get 2 raised to 5 equals 32. And our final answer is 32 equals 32.
Sample number 2. Solve for 16 raised to negative x equals 1 over 64. Step number 1. We write the equation so that the bases are the same number. So, we will rewrite 16 as 4 raised to 2 and 1 over 64 as 1 over 4 raised to 3. Also, by applying the negative law of exponents, this is equal to 4 raised to negative 3. So, our equation will be 4 raised to 2 times negative x equals 4 raised to negative 3. Step 2. Once the bases are equal, you can set the exponents equal to each other or equating exponents property and solve. So, for our example, we will apply equating exponents property and we will get 2 times negative x equals negative 3. Multiply negative x by 2 and we will get negative 2x equals negative 3. Divide both sides by negative 2. Our equation will then be negative 2x over negative 2 equals to negative 3 over negative 2. Simplify and we will get x equals negative 3 over negative 2. But since our numerator and denominator is both negative, we can rewrite it as positive. Simplify and we will get x is equals to 3 over 2. For our checking, we will substitute 3 over 2 for x. And our equation will look like this. 16 raised to negative 3 over 2 equals 1 over 64. And then we will apply the negative exponent law. Our equation will be 1 over 16 raised to 3 over 2. We will then apply the rational exponent. It will look like this. 1 over square root of 16 cubes equals to 1 over 64. Simplify and evaluate. And we will get 1 over 4 cubes equals to 1 over 64. Or 1 over 64 equals to 1 over 64.
Now, let's talk about exponential inequalities and property of inequality for exponential function. Exponential inequality is an inequality involving exponential expressions. In solving exponential inequalities if both sides of an inequality are multiplied by or divided by the same negative real number, the inequality symbol or sign must be changed. These are the property of inequality for exponential function. If b is greater than 1, then b raised to x is greater than b raised to y. If and only if x is greater than y and b raised to x is less than b raised to y, if and only if x is less than y, and if 0 is less than b and less than 1, then b raised to x is greater than b raised to y, if and only if x is less than y, and b raised to x is less than b raised to y, if and only if x is greater than y. Let's have an example.
Example number 1. Let's solve 3 raised to x less than 81. First, rewrite the equation so that the bases are the same number. 3 raised to x less than 81. Then, rewrite 81 as 3 raised to 4. It will be 3 raised to x less than 3 raised to 4. Next, apply the property of inequality for exponential function and solve. 3 raised to x less than 3 raised to 4, so the answer is x less than to 4. The solution set to the inequality is x is an element of the set of real number x less than to 4. To check our solution, you may choose any value of x that is less than to 4. 3 raised to x less than 81, let our x is equal to 2. Since this satisfies the inequality x less than to 4, so it will be 3 raised to 2 less than 81. So the answer is 9 less than 81. It's true, hence the solution is correct because it satisfies the inequality.
Let us move to example number 2. Solve 2 raised to x plus 2 greater than 1 over 32. Step 1. Rewrite the equation so that the bases are the same number. 2 raised to x plus 2 greater than 1 over 32. Rewrite 1 over 32 as 2 raised to negative 5. Apply the negative law of exponents, so it will become 2 raised to x plus 2 greater than 2 raised to negative 5. Step 2. Apply the property of inequality for exponential functions and solve. 2 raised to x plus 2 greater than 2 raised to negative 5. It will become x plus 2 greater than negative 5. Subtract 2 from each side. It will become x greater than negative 5 minus 2, and the answer is x greater than negative 7. The solution set to the inequality is x is an element of set of a real number x greater than negative 7. Check your solution. You may choose any value of x that is greater than negative 7. So 2 raised to x plus 2 greater than 1 over 32, let x equals to 0 since this satisfies the inequality x greater than negative 7. So it will become 2 raised to 0 plus 2 greater than 1 over 32. And the answer is 4 greater than 1 over 32. It is true, hence the solution is correct because it satisfies the inequality.